Today we're working on the very last section of Unit 7 notes, exponential equations. All right, these are equations where you have bases and exponents on both sides of the equal sign. Well, how do we solve these? Well, let's take a look at the directions here. Express both sides of the equation as powers of the same base. So you actually have to have like bases on both sides. Set the exponent of the common bases equal to each other. So which means once you have common bases, you can actually get rid of the bases and then set the exponents equal to each other and then solve. Okay, let's take a look at number 2. With number 2, I actually have common bases. So at this point, I can actually drop the bases and then set the exponents equal to each other. And if you look at what we have a quadratic because we have a squaring, so we've got to get one side equal to 0, so I'm going to add 3 on both sides. Now I'm going to try to factor in t-bar. If I can't do that, then I'm going to go to the quadratic formula. All right, in this case, I need factors of a positive 3 that'll add to give me a positive 4. Plus 3 plus 1 does work. I can t-bar. X equals a negative 3, x equals a negative 1. In this case, I have two answers. So what I have to do is I actually have to check both answers. I have to plug in negative 3 for x and check it to see if it works, and then I have to plug in negative 1 for x and check it to see if it works. And just to save a little time, I'm going to tell you they both work. All right, let's go down to number 4. With number 4, I don't have like bases. So now, here's the rule when you don't have like bases. To find common bases, it's either the smaller of the two bases or you have to go smaller. So the smaller of the two bases is 9. So you ask yourself, can I take 9 and raise it to any number to give me 27? And no, I cannot, because 9 squared is 81. So 9 does not work. So what I have to do is go to a number lower than 9. So a number raised to a power that could give me 9 would be 3. So let's talk about this. To rewrite 3, I could write it as 3 squared. And to rewrite 27 with a base of 3, it would be 3 cubed. So all I did was rewrite 9 and 27 another way where they have common bases. But now 9 was being raised to the x plus 1, so 3 squared has to be raised to the x plus 1. And 27 was being raised to the x, so 3 cubed has to be raised to the x. Okay, so now we have to do power to a power rule. So we have 3 to the, and this is distributive property, 2x plus 2 equals 3 to the 3x. Now we have like bases, so we can actually drop the bases and set the exponents equal to each other. So let's go over what we did. We didn't have a common base, so we looked at the smaller of the two bases. Could I use the 9? No. So then I had to go even smaller. I had to find a number that raised to a power would give me 9 and would give me 27. And I found that to be 3. So all I did is rewrote the 9 and the 27 using a base of 3 and then actually brought down their exponents. So I had to do power to a power rule. Okay, so now we're going to solve. I'm going to subtract 2x on both sides. And I get 2 equals x. Again, what do you have to do with your answer? Yes, you do. You have to check it. And in this case, 2 does work. So we're going to move on to the next page. Let's take a look at number 6. With number 6, I don't have like bases. Now here's the odd thing. I have a fraction. And it's kind of hard to work with a fraction. So I have to think, how can I write a base and an exponent so that it would give me a fraction? You're right, I'd have to rewrite it with a negative exponent. So basically, I'm looking for a common base for 9 and 27. I can't use 9, but as we did earlier, we used 3. So I'm going to write this as 3 to the negative 2. The negative 2 would give me a fraction, so it would be 1/9. And that's going to be raised to the x. And then I have 3 cubed for 27, and that's going to be raised to the 1 minus x. So again, 3 to the negative 2 is actually 1 over 3 squared, which is 1/9. So I rewrote it so I didn't have a fraction anymore. Okay, so we're going to do power to a power rule. So I have 3 to the negative 2x equals 3 to the 3 minus 3x. I have common bases, so I'm going to drop the bases, set the exponents equal to each other. I'm going to add 3x to both sides and end up with x equals 3. Then I'm actually going to take 3 and I'm going to plug it in. So in the calculator, I'm going to go 1/9 raised to the third power, enter, keep that answer on my screen. Then I'm going to go 27 raised to the, well, what's 1 minus 3? You're right, -2 raised to the -2 power, enter. Do the answers match? Yes, they do. So x equals 3 is my answer. Okay, let's move on to number 7. With number 7, I don't have common bases. So again, the rule is to take the smaller of the two bases and see if we can use that. 8 raised to any power going to give me 16. Well, 8 squared is 64, so it's not going to work. Okay, so we even have to go lower than that. All right, 4. I could use 4 squared, it'll give me 16, but 4, nope, can't get an 8 out of 4 being raised to a power, so I got to go lower than that. 2, well, let's see, 2 to the 4th power is 16. And 2 to the 3rd power is 8, so 2 does work. So 2 to the 4th is going to be raised to the 3/4 minus x. And 2 to the 3rd is going to be raised to the 5 minus 2x. Okay, so I'm going to do power to a power rule and end up with 2. Okay, 4 times 3/4 is 12/4, which is 3, minus 4x. Remember distributive property. 2 raised to the 15 minus 6x. Common bases, I can drop them. Set the exponents equal to each other. And solve. I'm going to add 6x to both sides. And get 3 plus 2x equals 15. I'm going to subtract 3 on both sides. And get 2x equals 12. I'm going to divide by 2. X comes out to be 6. I'm going to take 6, I'm going to plug it in and check it and tell you it works. All right, one more for the row. Number 8. 4 and 64. I need a common base. 4. Can 4 raised to any power give me 64? Yep, so I'm going to use 4. So this side's not going to change at all. And 64 is 4 cubed. So 4 cubed is going to be raised to the x plus 28/3. All right, bring down the 4 raised to the x squared equals, do power to a power rule, 4 to the 3x plus 3 times 28/3 in the calculator gives me, you're right, 28. Okay, common bases, so I can drop the bases. Set the exponents equal to each other. I have x squared equals 3x plus 28. I have a squaring, so I'm going to get one side equal to 0. X squared minus 3x minus 28 equals 0. Try to do two binomials. If not, I have to do the quadratic formula. Factors of a negative 28, that'll give me a -3 minus 7 plus 4. T-bar. X is a positive 7. X is a -4. I have two answers to check. And as I check them, they both should work. Okay, I think there were 2 or 3 that I did not complete in these notes. I know if I remember it was 1, 3, and number 5. I'd like you to complete those on your own right now and then bring them to class tomorrow and we will see how well you did.